Okay, I think I'm live now. Can someone confirm if I'm live? All right. Oh, can someone tell me what logic did you use for problem D if you solved it? Fourth is GP with map instead array. Okay. Fourth कैसे होगा? Okay, okay, cool. Okay, am I live now? Can someone confirm? Yes, Nathan says yes. Yeah, live, live. Yes, you are live. Okay, cool. Cool. So, we are gonna solve Codeforces Education round 129 today, rated for Div-2. I will be doing problem A, B, C, and D. Okay, today's contest was like very easy, I would say. Like A, B, C are brute force, D is also brute force with just some cap limitation, and that's it. Like nothing like out of the box in any of the problems. Okay, how many were able to solve like A, B, C, D today? Or like how many problems were you all able to solve today? Let's see. I think ABC, most of the people were able to solve today. Even for C, we have like 6,800 submissions. Okay. At least A and B have like almost similar number of submissions. Okay. Then C had just some brute force only. And then for D, like it was just some cap limitation. Priyank says ABCD, Rudrak says ABC, Shrub says AB, Vasu says 2, Rajesh says 4. Okay, real nice. I see many people were able to solve ABCD today. ABCD done, Deepak. Really nice. Okay. Solved my first C today. That's really nice, Rudraksh. Rajesh says ABCD and he says ABC. Okay. So I see almost most of the people, like almost everyone was able to solve A and B today. Some of you were not able to solve C, and some of those were also not able to solve D. Okay, cool. Okay, let's see. Okay, let's start. I think we don't really need to waste time today. Okay. Uh, okay, I'll start from problem A. In my personal opinion, I don't think like today's contest was a good contest. Like it was a very easy, straightforward contest. Can you speak louder? Is that so for everyone? Like, is everybody able not able to listen me? Let me just increase the gain. Maybe that will help you. Audio fine. Okay. Anyways, I've increased some gain. Okay, so hopefully it should be better now. Okay, cool. Voice is good. Okay, cool. Okay, let's start with the very first problem. Alice and Bob play a game. Alice has n cards. The ith of them has an integer AI written on it. Bob has m cards. The jth of them has the integer bj written on it. Okay, so we have two players, Alice and Bob. So we have Alice and we have Bob. Okay, Alice has n cards. Bob has m cards. Alice's cards have numbers a like a1, a2, so on till an, and Bob has what b, b1, b2, so on till b of m. Okay. Now on the first turn of the game, the first player chooses one of his cards and puts it on the table. Okay. On the second turn, the second player chooses one of his cards such that the integer on it is greater than the integer on the card played on the first turn. So let's say in the first turn, Alice played the move and she played AI. Then the next turn, if Bob has to move and he has to move with BI, then AI should be less than BI. Okay. And then again, let's say like if Alice had to play, then if they plays AJ, then AJ has to be greater than AI and BI both. Okay. So that is how the game runs. Whichever player is not able to make any move loses the game. Okay. And we need to return who is going to win the game. Okay. Now If some player cannot make a turn, she loses. Okay, cool. If Alice has 4 cards with numbers this, Bob has this. Okay, so this is the game, like standard game. So basic. Okay, so like for example, like first Alice actually played with 5. When Alice played with 5, now Bob has to choose any card which has value greater than 5. So he took 6. Then Bob took 6. Then Alice says that then she needs to take any one card which has value greater than 6. So that is 8. Or let's say like 10 is also greater. So Alice took 10. Then, sorry. Yeah, Alice took 10. Okay, now Bob has to take any card greater than 10. So he took 11. Okay, and then now Alice doesn't have any cards greater than 11. So Alice loses. Okay, and Bob wins. Okay, now you need to answer 2 queries. What if Alice is the first player and what if Bob is the first player? Okay, that is all you have to say. Okay, now if you notice, in the end, it all comes down to who out of Alice and Bob has the greater card. Okay, for example, what? My solution of D is hacked. How come? Okay, that's strange. Okay, I'll come to that later. Really interesting. Anyways, okay, cool. Let's see. So, what happens here is that just a second, I am curious, like why did it get hacked? Okay, I am hoping others will also get hacked at least. Okay, let's see. Okay. Okay, so in this one, it all comes down to whichever player has the largest value. Okay, so let's say A is the largest value of Alice and B is the largest value of Bob. Now, if Alice has to play first, Alice will put down A. Now, if Bob doesn't have any value which is greater, like if B is lesser than A, then since Alice made the first move, Alice wins. Okay. Now let's see the other way around. Okay. If Bob had to move first and they moved B, and if B was lesser than A, then also Alice wins. So in any case, if A is greater than B, Alice wins. And similarly, if you see, if B is greater than A, then if Alice moves first, then A is played, then B is played. Since B is greater than A, okay, Alice cannot take any other move, so Bob wins. And if Bob has to move first, then when Bob makes his turn, now Alice cannot move because A is smaller than B. So again, Bob moves. So if A is greater, then Alice moves in both turns. If B is greater, then Bob moves in both turns. But if A is equals to B, if A is equals to B, okay, then if Alice moves first, then A is played. Now Bob cannot play with B because he needs something greater than A. So Alice wins. And in the other way, if Bob plays first, then if we write B here, okay, now Alice cannot move because Alice needs something greater than B, but since A is greater equals to B, therefore Bob wins. And that's it. Okay, so these were the 3 conditions that you had to write. I'll quickly show my code as well. Okay, so this is the code that I wrote. All I've done is that I've scanned like both the arrays. Okay, and then my A has the largest value in the first array, B has the largest value in the second array. If A is lesser than B, then both times Bob will win. If both of them are equal, then when Alice plays first, Alice wins. When Bob plays first, Bob wins. Okay, and if A is greater than B, then both times Alice wins. And that's it. That is how you have to do problem A. I'm assuming everybody was able to do problem A, so we can move forward to problem B now. Okay, cool. Okay, why is nobody else getting hacked for problem D in my... Okay, it failed for this test case? No, it is passing for this test. Okay, I cannot see the hack test case. Okay, let's move on to problem B. Okay, now in problem B, we have Monocarp has just learned a new card trick and cannot wait to present it to you. He shows you the entire deck of 9 cards. You see that the values of cards from the topmost of the bottommost are integers, A1 till AN, and all values are different. Okay, so we have how many n cards. So let's say these are n cards. This is an, this is an minus 1, this is an minus 2, so on till a of 1. Okay, now then he asks you to shuffle the deck m times. With the jth shuffle, you take the topmost bj top cards. Okay, you take the topmost cards and place them right in the bottom. Okay, after then, using some magic, Monocross tells you the topmost card of the deck. However, you are not really buying the magic. You tell him that you know the topmost card by yourself. Can you surprise Monocross and tell me? Okay, so after doing how many m operations? Okay, after doing m operations of like b1, b2 till b of m, you need to find out whichever card is on the topmost value. Okay, so how to do that? Let me show you the test cases. Okay, let's take which test case? Let's take I'll take the last test case. Okay, 2 1 5 4 3. We have initially we have 2 1 5 4 3. Now in the next in the first move, top 3 cards were taken and moved. So top 3 cards. So you need to take these 3 cards and move. So top cards become 4 and 3, and then 2 1 5. 2 1 5. Then again, you take top 2 cards. Top 2 cards and move them. So it becomes 2 1 5 4 3. Okay. Okay. Then again, after this, you need to take top 1 card. So this card is taken and moved. So it becomes 1 5 4 3 2. Then again, you need to take 2 cards. So it becomes, you take these 2 cards and it becomes 4 3 2 1 and 5. Then again, 1 card is taken. So it becomes 3 2 1 5 and 4. Okay. Now, if you see, first 3 cards were moved. After moving these 3 cards, whatever cards we have to move, they are going to be removed from here. And these values actually come here. Okay. So let's say if these values came here, and instead of removing 2 cards, you have to remove 3 more cards. So you would have removed 4, 3 and 2, which is 4, 3 and 2. So if you see, you are actually removing from this stack only in a cyclic manner. First you remove 2, then 1, then 5, then 4, then 3, and then again 2 comes. So it is actually cyclic. So all you have to do is count how many values do you have to remove. It's cycle. Okay, so you have to take 3, then 2, then 1, then 2, 1. 3 plus 2 is 5, plus 1 6, plus 2 is 8, plus 1 9. So in total 9 cards were moved. So if you move 5 cards in total, this stack actually comes back to itself only. And then you have to remove 4 more cards. When you remove 4 more cards, these 4 cards will be removed and this 3 will be on the top. And if you see, this 3 is on the top. So that is all you have to do. First find the summation of all the BI values. Okay, and then find the mod of that with n, and whichever is the value at the topmost card, that is the answer. Okay, for example, let's say n was 6, and let's say summation of all BIs, where I is equals to 0 till m. Okay, all BIs was let's say 14. So what you have to do is, the first 6 cards will actually make this state again back to normal only. Then again 6 cards and then 2 cards. So this 6 and 6 won't make any difference, but these 2 cards will be removed from the top. Okay, so if you had like A1, like A1, A2, A3, A4 and A5. Okay, these 2 cards are removed and then A3 is on the top. Okay, got it. So that's it. That is all you have to do. You have to find the summation of all the BIs and then like find the mod of n, and that's it. I'll quickly show my code as well. Okay, so this is the code. All I did was scan the complete array, which has the positioning of cards. Then I found out the sum of all the BIs. Then I found the summation percentage equals to n, and then whichever is the value is present at some index, you just print that value, and that's it. Okay, so that is all you had to do. Okay, I'm pretty sure everybody knows problem B also by now. Let me read the chart. I see many people typing. Okay, D is DFS, BFS, GFS, recursion plus GP. Not able to solve question C. Okay. Priyank, did you in reverse to? Selecting wrong answer. Priyank, इसका TC दे रहा है. Not able to solve question C. Okay. So selection was fine according to the. Okay. Anyways, okay, cool. I think problem B is clear to everyone, and we can move on to problem C. I need to figure out like why my problem D got hacked. I still don't know what happened, and all my rating is gone now. Okay. Hacked means, okay, basically hacked means that somebody actually provided a test case with which my code is giving a wrong answer. Okay. And like the custom, like the whatever answer code that they already have with themselves is giving the right answer. Okay. So that is what hacked means. Okay, I am assuming like many people will get wrong answers, but I don't see anyone else getting hacked by now till now. Why is that? What other people did? DF, why do we do? Why is he DFS? DFS won't give you the best answer. What is happening? Just a second. Okay, cool. Chetan says I got hacked as well. Many people are getting hacked. You can add hacked status as filter. Okay. Recursion plus DP is still not hacked. I don't understand the point of doing DP in this case. Maybe there is. I am still not able to understand what this person is doing. Recursion, if it contains return f of x, yes, people are actually doing recursion plus, matlab they are actually doing memorization. Why did I not think of that? Let me see what done. Is it really like just memorization? When I was thinking about it, I thought like maybe like it won't, like memorization won't even be useful at all. Is he has also done memorization? Answer comma 1 plus all. Everybody is actually doing memorization. That's all you had to do. Okay. Anyways, okay, cool. Let's move on to problem C now. Okay, you're given two arrays A and B, both consisting of n integers. In one move, you can choose two indexes I and j and swap AI with AJ and VI with BJ. You have to perform the swap in both arrays. You're allowed to perform at most 10 to the power 4 moves. Okay, can you make both arrays sorted in a non-decreasing order at the end? Okay, cool. So what the problem is saying is, we're given two arrays A and B, let's say. Okay, so we have array A. Okay, let me write it with small a. And we have array B. Let's take this as 2, 3, 1, 2, and this as 2, 3, 2, 3. Now we need to make some swaps such that we swap, if we are swapping like AI and AJ, then we also have to swap BI and BJ. Okay, and while doing this, we need to ensure that in the end, both these arrays get sorted. Now, the thing to notice in this is that n is actually less than equals to 100. Okay, that means even if we do brute force, even if we make n square operations, it will work, because we have total 100 test cases. Okay, so like t is less than equals to 100. Okay, and even if we make like n square approach, so 100 into n square, which is actually going to give 10 to the power 6 only, which will pass. Okay, so all you had to do was write some brute force. How to do that? Let me explain. Okay, so let's say this A is actually the sorted array A. Okay, which means the sorted array A becomes 1, 2, 2, 3. And let's say this B is sorted array B, which is 2, 2, 3 and 3. Let's say right now my I is actually equals to 1, that I'm actually on the first index. Now I see if my this value, first index value, is similar to the sorted index value. It is not. For B it is same, but since for A it is not same, that means I need to swap this value. Now I need to find such index J such that A of J is actually equals to 1. A of J should be equals to 1 because we need 1 at A of I. And B of J is actually equals to 2. Okay. If we have any such case, then we can swap. Otherwise, we cannot swap. Okay. Cool. Now, if you see, sorry, A of J, small a of J and small b of J. Okay. Now, if you see at index 3, we can see that A of J is like A has 1 and B has 2. That means we need to swap index 1 and 3. When we swap index 1 and 3, this 1 and 2 are swapped. So 1 comes here, 2 comes here. Okay. And this 2 and 2 after swapping also remains the same. Now our I comes on to 2. When our I is 2, we need to see if index 2 is equal to the sorted index value. Since it is not, and here also it is not, then again we need to find some swapping. How to do that? We need to find some J such that A of J, small a of J is equals to 2, because in sorted we have value equals to 2, and B of J is actually equals to 2 again, because in sorted we have 2. Okay, and if you see again index 3 has these values. So now you need to sort 2 and 3. Okay, so when you sort these two values, it becomes 2, 3, and when you sort these two values, it becomes 2 and 3. Okay, now again if you see, now my I is equals to 3. A of I, sorted A of I has 2. That means my A of J should be equals to 2 and B of J should be equals to 3. Since A of J is not equals to this value, I again need to find some swapping. Plus that AJ is 2 and BJ is 3. If you see, these two indexes are same. That means I need to swap index 3 and 4. Okay, so if you swap, this becomes 2, this becomes 3, and these remain the same only, 3, 3. Now my I is 4. And if you see, at index 4, I4, these two values are already same and these two values are also already same. That means no swapping is required. If we are able to reach the end of the array using this logic, that means we need to print these values. These are the possible swappings that we need to do. Else the answer is not possible. That's it. That is all you have to do. Pretty straightforward brute force, and that's it. Okay, let me show you the code as well. Okay, so this is the code. I'll explain like what I'm actually doing here. What I'm actually doing is I scan the AI, like I scanned my A array, scanned my B array, made a capital A array and capital B array, sorted, made the capital A array as the sorted array of small a, and made this capital B array as the sorted form of small b array. Now what I'm actually doing is I'm starting my I from 0 till n, and if my small ai is equals to capital AI and bi is equals to capital Bi, that means this index is already like sorted and we don't need to sort this, so continue. Otherwise, you need to find some index after j which has aj equals to ai and bj equals to bi. Okay, if that is the case, then push these values into the answer, because you need to like print the answer as well, all the possible sortings as well, swappings as well, and then swap the values in A array and B array. Okay, And after doing this, you just check this again. If now this is true, that means continue that for this index we were able to sort. Otherwise, you just break out of this loop. A flag equals to 1 and if flag is equals to 1, you just print -1, that it is not possible. Okay, and that's it. That is all you had to do. I hope this problem is also clear to everyone now. Problem C. If anyone has any issues in problem C, they can just let me know. Okay. Okay. Now I understood why simple bubble sort was wrong. Thanks. Okay. How to improve approach. Just practice. That's it. Okay. Should we move on to problem D? Let me see how many people got hacked now. I know only 200 people have got hacked. That's it. That is not a good thing for me. My rating will definitely go down. Okay. I don't know why I didn't think about memorization. Like, I just thought that memorization won't be of any use because the numbers won't be repeated that much. Easy Code says JIT Jindabad. Okay. I didn't know people of JIT are also watching. Okay, why is simple bubble sort getting wrong answer? It shouldn't be giving you a wrong answer. Okay, if you use bubble sort before the like swapping and find out the sorted forms using bubble sort, I think that would also give you the right answer. Why your solution got hacked? That is something even I need to figure out. I don't know why my solution got hacked. I don't know at which test case it is getting hacked. Although even if I know, like it will be very hard to like see where I'm getting wrong. I draw recursion tree in last 5 minutes, then I use memorization. Okay, like I do understand like it might be better using memorization, but I don't really see like which all values will be getting like used twice. Like it is actually gonna be very big tree, and I don't like uh I don't know. I just thought like maybe not many values will be like repeated. That's it. 5111. This is giving wrong answer. Is that so? 5111. No, 5111 cannot. Oh, just a second. 5111. No, 5111 actually has. Oh shit. Uh I actually made a very like I was actually testing out my code. That's why I wrote this count, which is of no use. Okay. And I think I am typing. Oh shit. This is the wrong value. I am just printing this count for no reason. They shouldn't be here, and it should directly be count -1. Oh, come on. Is this like really the reason? Just let me just check if this is the reason. Yes, this is the reason. Okay. Okay. Like I thought we won't ever reach the state. Like I knew like we might reach the state, but I was just testing out my code for like I was just checking like if I will get a time limit exceed or memory limit exceeded. Okay, in the worst case scenarios, and I forgot to remove the C out, and that is why I got a wrong answer. Okay, can't really help it. Sir, in first question, NMR are different. Then how do you take N for both arrays? If you see, I'm actually scanning N, M, and N only because I sort the first array, take the highest value in some different integer, and then I don't need that n, so I'm scanning m in the same n only. That's why. Say, okay, I feel really sad for myself right now because like my equation, like solution for problem D got wrong answer for no reason. Let me just submit it. I think we can submit. A very silly mistake actually. Like if I just remove the last, where is my code? Okay, if I just remove this C out, okay. If I remove this C out, I think I should get an accepted. Yeah, see, this is accept. That okay, I was just testing out my code so that I am sure like it doesn't give me any wrong answer. So I had a C out here for this count, and that actually like made my answer wrong. Okay, anyways, let's come on to the logic of problem D. Okay, okay, cool. D is pretty simple actually. Okay, even though I got hacked, it is simple. Okay, okay, so you're given two integers n and x. We have n and we have x. Okay, now you may perform several operations with the integer x. Okay, each operation you perform is the following one: choose any digit y, okay, that occurs in the decimal representation of x at least once. Okay, so you have this x, choose any value y which is in the decimal representation of this x, and multiply this x with y. Okay, and you need to keep on doing this until the size of this number becomes equals to n. Okay, you want to make the length of decimal representation x equal to n. Okay, what is the minimum number of operations required to do that? Okay, let's see. So if you see, the way to do this is actually like, I'll just explain the last. Okay, let's take the very first case only. We have x equals to 1. Now if you see, this value only has 1 as its decimal representation. Okay, and like it is only has one value in it, 1. So 1 into 1 actually yields 1 only. So there is no way we can actually get a number with two decimal places. Okay, so for this answer is -1. Okay, for the next case, when we have 2, for the first operation there is no other choice than to make 2 into 2, which is actually like 4 only. Okay, cool. This is nice. uh yeah, okay, then for 4, again you don't have any choice, so you make 4 into 4, which is 16. Now you have two options: either you can multiply this by 3 or you can multiply this by 1. Multiplying this by 1 will actually give you 16 only, but multiplying this by 3 will actually give you, sorry, by 6. By 6 will actually give you 96. Okay, and then for 96 you can either multiply it by 9 or 6, and in both the cases the value will be a 3-digit value. So if you see, one operation here, second operation here, third operation here, and fourth operation here, so the answer of this is 4. Okay, and similarly for this one also, I think the summation that I just did with additional C out, that also got hacked. Is that so? Just a second. Yeah, that also got hacked. Okay, okay, then that C out is not the like reason why I got hacked. That is a relief, at least for me. Is there some way I can see like why, on what test case did I get hacked? I can't. Just a second. I need to see like if I'm getting a right answer for n equals to 5 and x equals to 111. Okay. Okay, okay, okay. This is wrong. Again, another silly mistake I found in my code. Instead of writing this one, I need to write q dot size is greater than 0. Yeah, now accepted. You can see after hacking phase is over, you'll use that hack input to hack others. Okay. बाद वाला भी hack हो गया. I have submitted it again. Maybe this will be accepted. I had another silly mistake here. Okay, so I might be getting a TLE. Okay, let me explain the approach now. First, I'll explain you why memorization doesn't work in this one. Okay. So if you see, I need the complete board actually. Okay. Okay. So if you see, let's take this test case 1342. Okay. So our n right now is 13. Okay, and x is 42. If you see in 42, we have two options, either multiplied by 2, either multiplied by 4. Multiplying by 2 gives us 84, multiplying by 4 gives us what? 168. Now we have two options, multiplied by 8, multiplied by 4. Multiplied by either one. Multiplying by 1 is of no use. Okay, so we won't do that. Either multiplied by 6 or multiplied by 8. So you'll get some number here, some number here, some number here, some number here. You will see that all these numbers are different. None of these are same. And after these also, if you try to make the tree, you will see that it is very rare. Okay, it is very rare that the numbers repeat. Okay. Anshul says will be hacked again. Let's see. Okay. Like my say is that the numbers won't be repeated much. I don't think so they will be repeated. Okay. Because I'll explain also why. Okay. So if you see, how do I explain this? Okay. Okay, I think memorization might work. Let me see what other people have done. Okay, so Jingli is actually doing. Let's see his code. I find his codes best. Okay, let's see what this person is doing. First, they have limit int equals to. Okay, so the limit is actually like 10 factorial. That's okay till n only. Okay, so this is nothing but 10 to the power n. Okay, so this is the limit till which we have to go. Perfect. Okay, can x. Okay, now after this, if you see, we are actually making a map with the name f, and what we're doing is answer equals to rec of x, recursion of x. In recursion, what we are actually doing is if x is greater than limit, return 0 because we cannot go further this limit. If f contains x, return fx. Okay, cool. Like if this value is already seen. Otherwise, what we need to do is if result is equals to f of x equals to infinity, int result, okay, equals to f of x is what? F of x is the value for this, okay, which is 0 equals to infinite. Okay, I don't really know like what this was, what we are doing here. But after this, we're actually converting the value x into string. Okay, then for every value in string, every character in string, we are finding the integer value of that thing. If it is greater than 2, the reason we are doing greater than equals to 2 is because it is not useful to multiplying any value by 0 because it will become 0 or 1 because it will remain the same. So we need values greater than equal to 2. If it is greater than equal to 2, then just return answer equals to result comma, okay, result comma, okay, result is equals to inf, okay, result comma 1 plus, okay, 1 plus recursion of x times d. Okay, so this is just straightforward, what do we say, memorization. That's it. Can't see the code. Oh, I'm really sorry. I thought everybody was able to see the code. Okay. Okay, so that is all you had to do. Okay, now it is making sense to me like why recursion might work. Okay, because let's say we had a number x. Okay, we multiplied it by 2 first. Then we multiplied it, like we multiplied it by 2, then we multiplied by 4, then again 3, then 2, then 4, let's say. And another case, we might have multiplied it by 4, then 2, then again 2, then again 4, then 4. If you see, this value and this value will actually give me the same answer. Okay, and since both of these will give me the same answer, okay, memorization might be useful. Okay, let me see if my latest code got Add, it is still accepted at least. Okay, like okay, so that is like how you have to do this. You just have to create this tree only, keep going into this recursion. Okay, using keep going into this recursion. Okay, using memorization, that every value you encounter, you just save the answer for that state. Okay, that is all you have to do. Can we prove using largest two digit will always work? No, using largest two digits will never work. Okay, like this is not the right answer. I actually thought like maybe using the largest value might work. Okay, but that won't work. The reason for that is actually like, let's say we had a value x and we multiplied it by 9. Okay, but after multiplying by 9, it might be that all the values became 111. Okay, and we might reach a dead state. But what if multiplying this x by 2 might give us some other value, and then like multiplying it further might give us the answer? So like multiplying it by the largest value or the largest two values won't be the best answer. Okay. What if larger digits give smaller digits? Yes, exactly. Okay. So that is how you had to do this. This is the code. Should I write the code like in this live only, a better memorization code, because I don't think like many people will be able to understand this code. If you want, I can write that. I don't have an editor on this machine. I can write it on HackerRank or something. By the way, how hard to become GM on CF can I become in 1 year? That all depends on you. Can you explain your logic? Okay, what I did was, I'll explain my logic. Okay, what I did was, I actually took a queue. Okay, let's say I have x. Okay, and then I multiplied it with all its digits, and let's say I had these values. Then I again multiplied it, and then let's say I had some more values. And then I again multiplied it, and then let's say I had more values. This is some standard BFS. Okay, I'll write the code. First I'll explain like why, like standard, like how you had to approach this problem. Okay, I'll tell you like how at least I approach this problem. Okay, so what I did was, okay, let's do it like this. Let's say in the start I had x only. After like doing one operation, we might have two values, either multiply it with the first digit or the second digit. Then let's say after, like when I had this value, I might get two more values through this after multiplying one digit of these both. Okay, and similarly for these as well, and so on. And then like I'll have some more values and so on till this will keep on increasing. And this is standard BFS. The reason why I'm doing BFS and not DFS is because I need to find the shortest route when I have the number of digits equal to n. Okay, and that can only be achieved using BFS, because in DFS it might be that the very first route that we are taking, might actually be the longest route. So either we have to do the complete DFS of the entire, like find all the states possible and then see the best answer. But obviously that will take a lot of time in memory. So I use BFS so that whenever I reach like the first value which has n equals to 13, like the number of decimals equal to 13, that is the answer. That is the best state. That is why I was using BFS. Now while using BFS, I observed that till n equals to 12, I am getting right answer. No problem. But if my n actually becomes greater than 12, I actually get memory limit exceeded. The reason for that is, I'll explain the reason. Let's say in the very first case, like when I had, okay, BFS is done using Q, everybody knows that. Let's say when I had X, my Q had only one value in it. Let's say in the next iteration, I had two values. Okay, two values in the queue. In the next iteration, I might have four values. This is the least number of values that I might have, because every value will again give me two more values. Okay, then in the next iteration, I might have 8 values. In the next iteration, I might have 16 values, and so on. Okay, so in every iteration, okay, my memory will increase twice, at least. This is at least. Okay, so that means when, like, let's say it took me 19 operations, okay, to find the answer, or let's say like we know the, like, since n is equals to, in the worst case n is equals to 18, and if you see for n equals to 18, x equals to 2, the answer is 21, I think, or 22, I don't remember. Okay, so the size of this queue in the maximum case would actually reach 2 to the power 20. And 2 to the power 20 is actually 10 to the power 9, something around 10 to the power 9 only. No, sorry, 10 to the power 7, I think, or somewhere in that case. Let me just check. 2 to the power what 20. It is 10 to the power 7 only. Okay. Okay. But before this, we were actually using all these memories as well. Okay. So in total, if you see, like, this will actually become 10 to the power 8 and you'll get a memory limit exceeded. We can use long queue. No, long queue actually, like, I don't know, like, what you mean by long queue. Okay. So that is why, like, using a standard BFS might give you the best answer. Okay. But it will get a memory limit exceeded. What I did was, I assumed that in my queue, let's say if this is my queue, it will have all sorts of values. I know that it is not of any use if I take the largest value and keep on pursuing that. We know that, like, and we saw that in this case. What I did was, I actually limited my queue to 1000 values, so 10,000 values only. I ensured that at any point, my queue only has 10,000 values. If I get values grid more than 10,000 in this queue, I only take the largest 10,000 values. Okay, and that is how I did it. That's all. Like, if you even try to see my code and understand it, okay, if you see my code, this is my code. Let me show it to you guys. What I'm actually doing is, I just have the standard BFS, and in this BFS, if you see every value, okay, let me explain the code. Okay, so I have a queue of pair. Okay, and in this, what I'm actually doing is, right now, initially my queue only has x0. X means the value right now that I have, and 0 is the number of operations that I have done. Okay, now what I do is, I find in this while loop, I find my size of the queue. Okay, I find the size of my queue, and then see, like, for every value in this queue, okay, I pop this value, I find the digits of that value. Okay, if the digits, the size of the digits is like greater than equal to n, then my answer is this only. Okay, otherwise what I do is, I multiply my current value abc dot first with every digit, and I insert that into a set. Okay, and after inserting that value into this set, okay, I take the topmost 10,000 values of this set and push them into my queue. Okay, and that's it. Okay, so at every state, like, for every, like, after every operation, I am making sure that my queue only has 10,000 entries, not more than that, so that I don't reach that memory limit exceeded state. Okay, now this is just some assumption that I did, that my topmost 1000 values will give me the right answer. Okay, until now, like, it hasn't got hacked, so I'm assuming this is also right. Okay, but the best solution would have been memorization only. I don't know why I thought that memorization wouldn't work in this one. Like, I thought, like, we will have very different values, varied values, so there is no point of doing memorization in this. But it turns out that that is the answer, and like, that should have been my first guess as well. But I thought otherwise. So yeah, that's it for problem D. Is anyone still not sure about problem D? I don't think so. This is going to get hacked now. So I think my solution is also right, this one. But yeah, like, in the contest, it got hacked. Explain memorization code. Oh, okay. I had to write the code as well. Okay. Okay. Let me write that. Okay. I don't have any editor, so I'll just open my hacker rank only. Login using. Okay. Just a second. I actually code using my Mac and stream using my Windows laptop, so like I don't have any editor. Let me just try this. Okay, I'm writing the memorization code. Okay. Okay. In the meanwhile, if anyone has any problems, like they can just ask me. Easy code says y 10,000. That is just some random number I took in order to avoid memory limit exceeded. Okay, that's it. Let's take my code. I have my template. Oh. So this need my template. That's it. Why didn't you use priority queue? I don't see like how priority use would have optimized my code. I don't really understand. Okay, so what is the input on this? I had nnx. Okay, so let's make those global only. And let's scan them. And we also need a map of int comma int. Let's call this dp. Okay, and we have what? Int solve int n. Okay, cool. Okay, so when I have x, I just need to return my, or let's say int answer is equals to solve for x, and if x is equals to inf, my inf should be 10 to the power 19. If x is equals to inf, answer is equals to -1, cout -1. Okay, and before this I also have an edge case, which is if x is equals to 1, not just 1, if it is equals to triple 1 also, and all those cases. Okay, I think I'll handle this in my code only. Okay, now pretty basic stuff. Okay, if I have already seen this, if dp dot find, first I'm writing all my base cases. If dp dot find n is not equals to dp dot find, and is not equals to, sorry, dp dot end, then I just need to return my dp of n. dp of n is to be returned. Else I need to find all the digits. I already have the code for digits written, so I'll take that. So I find the digits. Okay, so find digits, vector and digits is equals to find digits for what? For n. Okay. Conversion. Okay, that I'll handle later. Then after that, for theta equals to 0, I less than what? Digits dot size I plus plus. So for every digit, I need to again call this function solve for, okay, if digit I is greater than 1, then only do this. Digit solve for what? Solve for n times digit I. Okay, and this needs to be stored in my answer. Answer is actually gonna be minimum of answer comma solve. Okay, and now I need to assume my return dp of what, dp of n is equals to answer. I need to initialize my answer as well, and answer is equals to inf. Okay, so my answer is equals to inf for every case. Okay, I need one more edge case. If digits dot size is actually greater than equals to n. Okay, I cannot take n. Oops. This has to be like, let's say this is val, this is val, this is val, this is, this is also val. Okay, cool. So answer is equals to inf. Inf is already 10 to the power 19. Okay, my if digits dot size is greater than equals to n, then just return 0. If answer is not equals to, sorry, if answer is not equals to what, equals to inf answer plus plus, because we have made one operation here. Cool. I think this should be enough. Let me just change my int to long. Okay, let's see if this works. Let me just go through the code once again. I scanned an nx. I call my answer. If x is equals to inf, answer is -1, else count -1. Cool. Okay, what I'm actually doing after this is, for solve, if this value is already encountered, then just return me the answer of this value. Otherwise, make my answer equals to inf. Okay, then for all the digits in my value, if the count of these digits is greater than equals to n, then I have already got an answer. Okay, if I have already got an answer, then return 0. Otherwise, multiply this by the digit. Yeah, get that answer. Cool. And then that is actually answer plus plus. Cool. I think this will work. I don't see why this won't work. Let me just test this out. Let me close all these. Let's uh let's take the second case first. I don't see any comments. If anyone has something to ask, they can just ask me. I am getting -1. Weird. Let me see if answer is equals to. Okay, for 3 2 I'm getting 4. Let's see. Let's see for the last test case. Runtime error. Let's see. Let me just check for the first test case as well. Okay, for the first test case also I'm not getting the right answer. I think there might be some issue in this INF as well. How do I resolve this? Let's say 10 to the power this. Let me just say I have what, 9 9 times INF. I think this might be the issue. Let's see if this works now. I think my INF is not able to get stored in answer. That's why I'm getting this. Yeah, for 2 1 I'm getting a -1 now. Let me look for this one as well. I hope this works. Come on. No response. Huh. Does anybody see any problem with this? Ah, let me just see. So what I'm actually doing is return dp val. I am returning dp val. Just like marking it that equal to answer as well. dp val. Yeah, I think I'm doing that. Oh, dp of val. Sorry. Really sorry. Okay. Again runtime. Let's see. Okay. Then it's perfect. Then I have val. Instead of number we can use string. Will that be helpful? Like that would optimize actually. Just a second, let me see if that is helpful. Should I try with the string? I don't really know like if that will work. Okay, let's try this with a string. Maybe that will work. Okay, let's see. Okay, this is not working for 13. It will actually decrease. Okay, let me just give it a try. Maybe it might work. Let's say this is string digits equals to we can use two string. Okay, now this is of no use. Okay, now digits dot size. Okay, cool, perfect. This has to be digits of I minus 0 is greater than 1. Then multiply this with digits. This needs to be multiplied this now. Okay, let's see if this works. Still not sure like if this will work or not. Runtime error. Okay, this is strange actually. I don't. Hey, can anyone else for multiplication we need to use carry? No, that is like using big int is of like I don't think we need any big int libraries here. Uh, how should we handle this? Let me see if there is any depth with the other code that Jingli wrote. So what that person is actually doing is okay. Let's see if this is working for 10. Is it working for 10? Runtime error for 10 as well. Is it working for like 5? Yeah, it is working for 5. I think I'm doing something very silly. For 9 also it's working. It is breaking on 10. Int map long dp string long. No, I don't think like that would actually like help us in any way using a string instead of map. instead of long. Value को भी string में करना है. No, I don't think that is useful. Is it? I think it should be like value, like integer only. What I'm failing to understand is that what difference do we have with the other code that we saw? Remove. Okay. Let me like open up the other code as well. So this is the code that we saw is working. So what they are doing here is answer is this, answer is equals to this, then -1, see out answer. Okay, perfect. Same thing we have done. Then in recursion they are writing if the value is greater than limit. Okay, if the value is greater than limit. Let's say if we actually reach 111 here, and for 111, we try to do what? Since there are no digits for 111, it is going to get dp of val is equals to answer. No issues. So I don't think like that is of this case is already covered. Where like that is already covered. I think like I don't really need this return 0. Oh, dp val is not equal. Yeah, my return 0 is here, so that is covered. Okay, then after this contains also I've written. This is the same thing only which I wrote. Then for string, I have handled for string as well. Return equals this. I have written the exact same code, but I am getting a wrong answer. Like time limit runtime error. Uh, if value into this is less than n, then only call recur. Just a second. If value into digit okay is less than n. Why do I have to do that? Okay, because like even if this becomes greater than n, okay, I will quickly figure that out in my next call. So I don't think that is the break. Oh. Okay, let's not waste time in the stream. I'll figure this out after the stream, submit my code, and then you can see it. Okay, and maybe parallelly, even if someone else is able to do it, they can just let me know. Okay, although the other code which I wrote is right. Okay, it is giving a right answer. I'll show that code. Uh, yeah, this is not hacked, so you can use this code. What I've done is I've done a standard BFS, and I have just made a cap limit of 10,000 for the queue. That's it. J says if d dot size equals to n, return 0. If d dot size is greater than n, return limit. Why? No, even if it's greater than n, then also we need to return 0 only. Although it won't ever be greater than n, it will first reach like n only. Line 18, no return. Oh, sorry. It is silly. Yeah, it's working now. Let's try for 18 only. No, let's try for 13. Why didn't I see this? Yeah, it's working for 13. Let's try the worst case scenario, which is 18 too. Yeah, this is working now. Okay, so this is how you had to do it. Let me just submit this code as well and see if it works. Yeah, it is working. Okay, so this is the code. Maybe let me open my code only. Okay, so this is the code. Standard memorization NDP. That's it. Like nothing else, and that works. Cool. I think that's it. I think I can end the stream now. Won't the map have at least 10 to the power 8 numbers in the worst case? Preliminary limit exceeded. Just a second. I think we will reach an answer before that only. That's why, like, no, we actually saw like, if you do like, the worst case will have 2 to the power what 20 values, which is actually this 10 to the power 7. So we can actually store them in the map. Okay, cool. Sir, I'm in third year. Done a little bit of CP when I was not able to solve two questions in today's contest. Whether I should focus on DSA lead code also, I'm doing an internship. If you're already doing an internship and if you think you can get a PPO there, keep doing. Like in any case, I think you should keep doing DSA. If not Codeforces, maybe lead code. Okay, but don't miss out on DSA. If not now, it is going to come really handy in like future cases. So like never skip on DSA. Either do it from lead code or you can do it from Codeforces as well. Okay, cool. I think that's the end of the stream. We did problem A, B, C, and D. Okay, and what? We have the next contest on 25th, I think. Yeah, 25th, Div 1 and Div 2 round. So let's meet on 25th. Again, like it's okay. The timing is what? The contest starts at 11 p.m. Okay, like why is this? I think the timing will get changed. Like for now, it says like the contest will start at 11 p.m. 11:05. Okay, which shouldn't be the case. It's a 2 hour 15 minutes contest, so that means it will end at around 1:20 in the night. So hopefully the timing will get changed, and I'll meet you all on 25th. That's it. Cool.